let's get started. Next up is Paul Kocialkowski, and he will tell us about a way he's been figuring out how to make installing open source firmware on your computer, to make that as easy as installing it like Linux distribution, like Ubuntu or Fedora. So, give a round of applause for Paul Kocialkowski.
Okay, hi everyone. So during this presentation, I'm going to provide some insight about what the firmware and boot software situation is like for hobbyists and for people who are technical users who are interested in actually getting involved in the technology to a larger extent than just using it. And so I will present some of the issues that arise when trying to do that, and what are the points of complexity, and what I've tried to do to mitigate these issues and to kind of move forward on these topics. So first off, I'll focus on digital technology and end users on a kind of broad sense. And I will start by telling you a bit about how digital technology is made and what impact it has on end users. So if we look at the proprietary industry, there are some observations that we can make. And generally, the end users are treated like consumers. And not just clients, but consumers. And this means something nearly political. It means that the consumers are passive, and they're just going to try to use the technology and nothing more than use it. They're not going to be interested in understanding how it works, or in changing it, or in owning it in any way. And so the expectation from that is that, well, the technology should just work, and it should always do the right thing, and it should always serve the user interest. But of course, this approach is really not neutral, because if we consider these assumptions, the technology that is developed this way is made in a way that only the developers have the exclusivity of the knowledge, and actually when you have the exclusivity of how something works, then you're the only person who can have effective control over that. So it means that there is sort of a walled garden, and only a few people in society are in that garden and have the access to the knowledge, to the control, and in the end to the power to really act upon the technology and to decide how the technology works and what it does and what it doesn't do. And so this is really a fundamental question of what do we want technology to be in that sort of walled garden at the society scale, or do we want it to be something accessible to everyone who basically wants to get involved at sort of technical levels? And when we have this situation, the hierarchy of interests may not be the one that is in the best interest of users. Of course, when it's groups of developers, and especially companies that decide how the software is made, they're going to do it with their own interests first. And that's natural. The people who do the work do it in their interest. And those interests don't always align with the interest of end users. And nothing to match this, we can have technology that will refuse to cooperate with users, and that will refuse to do what the user wants them to do. And so that's the example from 2001 Space Odyssey, where the machine says, well, I'm sorry, I can't do that. You're asking me to do something, but I'm a machine and I'm refusing. So we have a problem here. And if we look at it on a very broad scale, digital technology nowadays is everywhere in our lives. It's in our communications, it's in the way we interact with other people, so in everything social, all the information we access, and we use devices that have very extensive input and output, so there is a lot of data collection going on. The devices know where we are going, what we do, who we talk to, and basically everything about us. And all that data we send to some infrastructure, and well, what data do we send, and to whom, and under what conditions, and to do what with it? And so really, digital technology affects every end user's life. And because of that, the way it's done is going to have consequences about these users' life very directly. And if we take a step back and look in literature how this problem was perceived, it starts with Frankenstein's monster complex. The idea that a scientist will build a piece of technology, well, Frankenstein's monster is kind of technology, that will eventually rebel against its creator and do something that is not in its interest. And because of that, Asimov thought of the 3 laws of robotics that would be ways to prevent the machines from harming their creators. And this this takes the assumption that the machines are independent from humans, but we all know that they're not independent. The machines just do what the people who build them to do. And so this is shown with Orwell's Telescreen in 1984, where it's very clear that the technology is just a way for the power to impose restrictions or to have active surveillance on the population. So this is not really something new, and this problem has been known in literature for a while. Except that, first off, we thought it was separate creatures that eventually turned into robots that were still independent, and nowadays it's clear that it's really computers that do not necessarily obey users, but obey the people who program them. And this is why I believe we need to embed guarantees in technology that allow to revoke developers' privileges, meaning that they are not the only people in that walled garden that can control the technology, but that all of society can do it if they want to. So it doesn't mean that everyone has to be a developer, but it means that if anyone wants to become a developer, they should be allowed to do it. And basically, users should be allowed to own their technology this way. And this is not just about individual ownership, it's also about society-scale ownership and basically being able to ask a contractant or anyone to, well, look at this piece of technology and make this or that change, or ensure that it's doing this and that and not this other thing and that other thing that you don't want. And basically, this is formalized by free software for freedom, the freedom to use the software for any purpose, the freedom to modify the software, and the freedoms to distribute it either in its original form or modified. And the implications of this are, well, individual and collective control, that, as I said, any member of society can decide to take control over the technology. It also means that users get to decide who they trust. If they have choice between different software, and if they're not locked down with just one software that they can run, then they can decide, well, I have different choices, different options, and I can choose based on my own values. And to make that effective, the distinction between hardware and software is key. It's basically the nature of technology that both aspects are distinct, and so there is just no good reason why one piece of software should be tied to one piece of hardware and vice versa. It should always be possible to replace one aspect of technology. If you have just hardware that is supposed to run any software you program it with, then that should be the case in practice. It shouldn't just be the software made by the manufacturer of the hardware that is allowed to run. And that means that we need access to knowledge. And when we have access to knowledge, then users no longer have to be passive. Of course, they can stay passive if they want to. That's not a problem. But the point is, they should have the choice. So the bottom line is freedom empowers user, and it also allows to sanitize digital technology on a society-wide scale. But if we look at it, the way that the software or the technology, especially the software, is developed is not always on the same grounds. So first off, we have upstream. So upstream is the idea that the code that is made will be made in common. So it's not just someone who's taking that code and developing it in the corner of the world, and that's it, and then they're not touching it anymore. It's rather the idea that we're going to do something together, and that the code base will be common, so that all the different features, all the different use cases are integrated into one tree, and then it's much easier for maintenance. because that way you don't have 10 million different versions that everyone modified in a subtly different way. You just have one piece of code that you have to maintain. So for security, there is a huge benefit because the improvements that are brought by one person to that code base will benefit all other users. And so this brings the focus on the long term rather than short term. And on the other hand, we have so downstream, where the code is done in a quick and dirty way, where the modifications are specific and the updates are often not provided. And this is driven by short-term focus. So usually time to market, meaning that we have to get a product out as fast as possible, and so we don't have time to do things in the long run. We don't have time to actually commit the code to a common repository, to have it reviewed by peers and things like that. But thankfully, some companies still manage to meet the time to market goals and also do upstream, so that's a really, really nice thing to have. So upstream, we can say that it stays relevant across time, while downstream is really fatally outdated. So if you get a piece of software that's downstream that doesn't get updates, it's going to be useless after a period of time, and there's just no way around that. So with this consideration, we can say that deprecated software is really considered harmful, especially for security reasons, because bringing updates to software is just a natural and very desirable thing to do, and not updating software is actually abnormal. Unlike different types of technology, like hardware, where you do it once and you expect it to work, software is something that should be perpetually evolving. It's a bit like if you were driving a car and you would never ever have any technical checkup at any point in using it. Then for how long would you use it? I mean, the longer you use it so the longer you use it and the craziest it gets, the more dangerous it gets, because you have no guarantee that there's no problem with the technology you're using. So that's all pretty theoretical. It's not very practical, and well, those ideas are maybe interesting, but for end users, what does it really mean? So if we look at it, digital technology, as I mentioned, comes in different things. You have the circuit board, the integrated circuits, then so logic configuration, which is what you find on FPGAs like this, and then in the end software that are the instructions. And so some of those can be reprogrammed and some of those are fixed. So the hardware aspects are always fixed, and software and logic configuration, you can actually reprogram. So what is the state of free software on digital devices? So nowadays we have lots of systems and applications that work, and those are divided in two categories. You have those that are generic, like the user interfaces and all the applications, and those don't depend on the hardware. But on the other hand, you have all the hardware-specific support, which is what we people usually work on. So that's for the system part. So hardware-specific support is usually in the kernel, and nowadays support in the Linux kernel is pretty good for a wide range of devices. But what about boot software and firmwares? Well, the situation is that most of the time they come pre-installed with the device. So it means that it's not actually expected that this will get updated. So of course there are exceptions, like the Chromebooks, for instance, where the firmware update is all part of the update process and it was really thought through. But on the widest variety of hardware that you can find in shops, the boot software and firmwares are just installed once and they're expected to work and to never be updated. And so that's a problem. And this makes the situation rather complicated for free software. And if we look at it, boot software is really critical for freedom, privacy, and security. especially because boot software is also the root of trust. It's the first kind of software piece that runs on the device. So if that software is compromised, then the whole chain that follows it cannot be trusted any longer. So for security, there are especially huge implications. So in the free software world, we have significant boot software. So we have, I mentioned core boot and U-boot. Core boot covers lots of Intel, well, x86 devices, also a few ARM and MIPS ones, and also RISC-V is upcoming. And on the other hand, we have U-boot that really is about embedded devices. So that might be single board computers as well as phones or tablets and mobile devices. And with those two, we can already cover a good span of devices that's many types. There are also other projects that are less known, but also quite interesting, sometimes have technical advantages over others. So that's Barebox and Little Kernel. And on top of that, you have payloads that are sometimes called bootloaders, although the distinction can be a bit blurry. You have CBIOS, Tyanocore, Grub, and depth charge. So those are payloads for core boots. U-boot usually has its own kind of interfaces to boot up. And these also provide the user interfaces in the end for the users. But we also have the privileged execution mode, which is something that came up rather recently, I would say. So ARM Trusted Firmware is the reference-free implementation on ARM. There is also something called UpT, which is not actually at the same level as ARM Trusted Firmware. So UpT is rather on the privileged execution mode. It's a system kind of equivalent. And in this privileged execution modes, the software that runs has the highest level, well, as the name indicates, of privileges. So it means that it can have access at all the hardware. It can forbid the main operating system from accessing some of the hardware. It can, forbid operations like this. So it's also really critical for privacy and security, because if in that privileged execution mode you have non-free software running, then you basically cannot trust what the main operating system is doing. And that stuff is always, it keeps running on the side of the main operating system. So implications are high. Now, for end users, hobbyists, and people who would like to actually replace the boot software with free projects and also the firmwares, like they do with the system. And with the system, it's actually not so hard. There are installation guides, and they apply to lots of different systems, and it's usually something that people can do. And although not everyone has the ability to install their operating system on the machine, it's not hard to find people who can do this, and there are usually install parties and things like this, where people gather together and they help those who don't have the technical knowledge to do it. And the point is that those people who can actually replace the system don't have to be developers, because there are enough instructions and the process is simple enough. But if we look at the firmware and boot projects, then it becomes a lot harder, and finding people who actually know how to replace these pieces of software with free ones is very complicated. And there are also additional limitations in addition to the sheer technical complexity. So the main problem we have is enforced signature verifications. So the idea that the boot software will be signed with a cryptographic key that is fused in the hardware itself. So the public key is fused in the hardware itself, and it will be used to verify that the boot software that was installed matches that key, so there is a signature. And if it didn't match, then what's going to happen is the device will be turned into a brick, because the device can no longer boot, and the device will just refuse to work. And that is a very clear indication that these devices and platforms are fatally flawed. If they're not able to do what the users tell them to do, then there's a big problem going on. And it's really the idea that in those models that are often presented as security, but it's security always depends on the threat model and on who it serves. So in that case, it's security, but security for the manufacturer, not for the user. The user is actually considered to be a threat because they're not allowed to change the software by themselves. They have to trust the manufacturer, and maybe the manufacturer is just not in the trust model of the user. Maybe for whatever reason, the user decides not to trust the manufacturer, and they should be able to do it because, again, the hardware and the software are two distinct aspects that should not be intrigued one with the other. So for this reason, the platforms that have and the devices that have these limitations, I consider to be fatally flawed and really not very interesting for the cause of liberating devices and empowering users. And of course, even when we have a hardware that is somewhat cooperative, the free projects don't always have the full extent of hardware support. So it really all depends on the project, and it all depends on the platform and the device that is used. And most of the time, this status is not very clear to people from the outside who would like to start using these projects. Very often, the people who do the development are aware of the current status, but it's rarely formalized. And so the next step for a technical user who would like to replace the firmwares and boot software with free ones is integration. So how do you get images to install? With systems, it's easy. You just install software with the package manager, right? And you find live CDs that you can just boot, and that's it. But with boot and firmware, it's rare to find pre-built images. And the system distributions don't include the firmwares and the boot software. It's all taken out of the scope, and it's assumed to be in that state where it's already installed and working, and we don't have to care about it. So that makes it even harder for end users. And again, the documentation for the process of building the images, like what config to choose and which options are right to select, is not always very obvious. So it requires heavy lifting to go through the whole process from finding the configuration to building to packing the image in the right format and finally installing it to the medium. And so that requires knowledge and skills which are kind of above the scope of just replacing the software. For the system components, the users don't always have to find how to configure, how to build it. It all comes prepackaged. It's integrated and it's easy. And so why is boot and firmware so very different? Also, one of the downsides is that the procedure might be very specific to the device or to the platform because it often requires more than just installing something from one place to another. You might have to actually open the hardware and mess with some, you might have to connect an external flasher or probe to access the storage where the firmware lives. So the situation now is that it kind of requires developer skills. So the people who do this know how to set it up and how to get it going, but for others it's pretty hard. So this is when the Origami paper comes in. So globally, it's a project that provides means to to ease the development and preparation and installation of free software and logic configuration projects related to hardware support. So that is pretty broad, but really the underlying mission is to abstract these technical steps and to provide some entry points, some interface that is not as complex as it is for the developers. So this means providing tested revisions and configs. So making sure that everything that is integrated actually works, that it was tested, because it's also hard to know when you just download the source tree for a project, what is the state of things now and what works and what doesn't work. So it's also about tying projects together because there are some dependencies. Once you want to, for instance, run a specific boot software with a specific payload, then you have to kind of integrate the two correctly, and that may not be obvious to users as well. Also, the steps for each device have to be documented, and so the idea here is to provide all of that and in one place. So it's kind of like a distribution, but not a system distribution, rather a firmware distribution. And the focus of this is to only, only care about the devices that are relevant for freedom. So it means not the devices that are fatally flawed with the signature verification problem, but instead focusing on the devices where you can replace it and where the status in the support status in the project is sufficient to actually do something useful with it. And the focus is also put on upstream projects. And in cases where there are non-free components required, then we just remove those components and the supported devices will be able to still function to some extent without these blobs. So that's how it's done. So the first component here is the build system, so it's written in Bash with lots of helpers, and the idea is to provide simple actions like build or download build to do one step of the process, but in just one call. And eventually, the idea will be to have releases for the images and the tools. There are also setup scripts that help actually install the stuff on the device that can use directly the built images or releases. And it looks like this. So the idea is you just have one single command line, so paper build uboot for the QB board 2, and that's all it is, and it will build all the dependencies and everything that's required. It will use the right config, and in the end, you have one image that you can install with the scripts, and that just works. So paper deploy is an attempt to kind of tie together the build part and the image preparation and packing with the installation. So in that case, you don't have to use the scripts in a second step, but it's all done in one step. So it has to be configured like this. You just provide the device you want to use, the boot medium, where to install it, and the path to the build system, then just paper deploy uboot, and it's going to do the same thing, install it to the SD card, and then you can just take it out, put it on the device, boot, and that's done. So the idea is really to do it in one go. And so that solves some of the issues that I've mentioned, but there is still the problem of knowing what features work and what doesn't work. So to solve that, I've started some sort of a static database where there is basically per hardware feature status. So the status looks kind of like this. So you have the different things like DRAM. Okay, on the QB board 2 and U-boot, is it supported? Yes, it's supported. And so you have that for every hardware feature, and it gives visibility and makes it very clear that, what can be done, what can be used with that. And there is also a special criteria about missing. When a feature depends on non-free software, it's considered to be missing because we only care about the free, the extent of support that goes up to free software and not anything beyond that. So the current status of the project is that a few Arduino devices are supported, but also many Chromium OS devices, especially the ARM Chromebooks. So that's Tegra K1 and the 2 generations of Rockchip, ARM v7 and ARM v8. Those components are, some of those are actually already usable. Paper and Paper Deploy I've been using for months and years. Paper support and documentation per device is still in progress, so I'm working on that. I'm also working on a website, mailing list, and source code hosting, and everything so far is available on my personal Git. so it can be tried out already. And in the future, we want to integrate more platforms, especially so some ARM devices, again, because those do pretty well when it comes to free software. And also have reproducible builds would be something very nice. And eventually distributing the binaries and the source, and in the end, integrating that in free systems like Parabola or Debian or whatever, so that you can just install that from your package manager, and that would make things a lot easier. And in the longer term, I'd like to have a graphical UI for these command line tools, so that it's just buttons to click, and it gets really, really easy this way. So there is a workshop organized Friday at 9. The idea will be to help porting the GM45 Intel laptops, which also work pretty well with free software and without blobs. So we'll try to integrate these in Origami Paper. And that's it for this talk, so thank you. And if you have questions, that will be with pleasure.
Thank you so much. So, are there any questions? I can't see any. Oh, over there.
First of all, I want to say I think this is a pretty cool thing you're doing. This is really, I think, addressing one of the things that aren't really addressed well yet in the open source firmware world, this whole putting all the different things together. But I'm curious about how serious you are about the no blobs rule, because as we all know, it's sort of an unfortunate truth that there's hardly any completely blob-free devices. So are you going to completely never allow any blob devices in this, or are you thinking about maybe?
Yeah, that's the idea. So it drastically reduces the scope of devices we can support, but it's also intentional because it shows that, hey, look, only a very small number of devices can be supported by this. So in a way, it's also kind of to create incentive and to say, well, if you want more devices supported, then it would be good that the situation changes. And yeah, so it's not a very strong incentive, of course, but it's also less work for me, so well.
Yeah, I mean, I think the problem I'm seeing is it would be cool if something like this could take off as the firmware building mechanism that we all use, but I think you might have a hard time like gaining traction with only supporting so few devices.
Yeah, well, it's also supposed to be something for a very specific vision and use case. So it's for people who want to run. Maybe I didn't put the emphasis on that too much, but it's for people who really want to run fully free stuff. And that's kind of why I've done that. It's not so much to support as many devices as possible, and also it's for those few devices that I'm really interested in and that I want to provide tight integration for, basically.
Okay, I have actually a question. Earlier you told me that Origami Paper mostly consists of scripts.
Yeah.
So it's a collection of scripts, but later in your talk you said that you're planning a binary distribution. So how much of your code is, like what does your code base consist of at the moment?
So, a collection of scripts is not a bad description. The idea is it's, mostly bash scripts tied together that provide this level of integration. So I think that the interesting part about the project is not so much the technical part of it, because that's just scripting and things like this. It's really what it's used for. So to provide images in the end. So I'm not sure that really answers your question, but
yes, it does.
Okay.
Okay.
So you mentioned that basically the fact that firmware, for instance, is signed with the manufacturer's key doesn't provide security to anybody but the manufacturer.
Right.
So isn't there a contradiction? So if there is a device which doesn't require any verification for booting, and somebody owns it, then unbeknownst to the owner, this could be replaced, and could become infected with all kind of stuff. What do you think about this?
Yeah, so yeah, maybe saying that it's only that signatures only cover the manufacturer's security issues is maybe saying too much. But yeah, so if the question is it better to have a security model that is tailored for the manufacturer or no security at all? I think it's a very personal question to answer. It depends on the threat model. If the threat model directly involves the manufacturer, then it's probably better to have no security at all, because that way you can still run the code you want and you still have better guarantees than running just one binary that's signed by the manufacturer and that you don't know anything about. So I think it's really a matter of personal choice, and security, I don't believe security is something you can answer in objective terms. It depends on the situation. It depends on what you want to protect yourself against. There's no just security. It's security versus some threats. So it depends on the threats. And of course, for many people, it might be fine to agree that the security model will be the manufacturer's security model, even if it includes the user as a threat. That might be fine for some users, but I know lots of people for whom that's just not workable. That just doesn't fit the bill. So that's my point. And again, this project is for end users, but also people who want to regain full control over their devices. So in that sense, with that scope, it might make more sense to have no signature verification at all than to have signature verification imposed by the manufacturer. I'm not saying this is a case for everyone or this is a general statement. I'm saying that there are use cases where it's relevant, and currently no one is interested in these use cases at all, so that's kind of why I'm also providing that.
So, are microcode blobs?
Yeah, I think so, yeah.
Okay, so no updates for Spectre or anything?
Well, sadly. But this is mostly for ARM stuff, and on many of those there is no predictive execution, so no Spectre anyway, but well, that's a side point.
So in the real early days of Linux BIOS, we had a web page that was like the ROM-o-matic web page, and you'd come in and do a couple drop-down boxes, and it would give you a button, and you'd download your image. And it didn't work because for a given name of a board, the vendors kept tweaking things. So that for a given model, like even a very long product part number, they still tweak things and buried the differences in the firmware. Does that happen in the boards that you're targeting, do you think, or are they all kind of always be wired the same way?
Yeah, there is kind of this expectation, and it's a problem, yeah, I agree that providing fixed configuration kind of assumes that the devices are all the same, and this may not be the case in practice. So yeah, there's a problem there. I'm not too sure how to tackle that. Maybe, yeah, making different device names in the build system that each match one of the configuration. That's not ideal, and I don't have really a good solution to that.
You may need to have a serial number, believe it or not, it'd be awful.
Yeah, it's going to be awful, probably. But in many cases, though, you can this approach still kind of applies. Like for various types of devices, it's just always the same. So yeah.
Can I ask one more question? I got to ask one more. So the really neat thing would be if you were able with something like that to get into early stages of design cycles. In other words, a vendor designed a board to work with this. Mm-hmm. So I don't know, it's just a thought. I don't know if that's even possible. But
yeah, maybe some kind of runtime involvement could work. Like you run a first piece that detects the specificities of the device, and then you feed that back to the build system, and so it cooks kind of the right image. So
it's like literally that there'd be a product from a company that said works with origami. You know what I mean? So they, when they laid out their PC board, they would have it in mind that they're doing a product designed to work with this thing you're doing. Okay. So you get actually into an ODM at like the very early stages of the process of design.
Okay.
So just a thought.
All right. Yeah. Oh. Good.
Are there any more questions?
Are there dependencies on online resources? How many? What is
Sorry, dependencies on?
Are there dependencies on online resources, like download something?
Yeah, that's something I didn't mention, but I would also very much like this to be kind of contained, so that you could put all the required stuff on like a USB stick, and you wouldn't need to download anything extra to get everything to build and to set it up and all. Yeah, I'm thinking more and more about like people in Cuba who have very expensive access to the internet, but who can still get stuff like USB media and things like that. And these people also deserve to have access to free software. So yeah, I would very much like, and I will try to make it so that this project can be kind of contained, and you can have a release that's just sufficient to rebuild the image, so I'll also be able to modify it, right? Not just binaries, but to have all the sufficient source code to rebuild images, and yeah, that's very desirable, I agree.
Also, what I saw, what would be important for at least long time stuff, it's that any online resources, that they would be archived in any way, maybe archive.org or something.
Yeah.
So often locations, maybe for very specific devices, the web pages were dropped, and so you're just lost because you need tool A or B or something, and it's not accessible anymore. So my idea would be to have everything, to build some specific firmware, to have it archived or in parallel archived at maybe one of the archive repos.
Yeah, so the solution I would have to that is, so in the releases, I mentioned I want to be doing releases at some point, and it's not just binary releases, it's also source releases, and so you can mirror that, and you can make it so that it's spread all over the world, and that eventually the knowledge doesn't disappear, because indeed that's a pretty serious problem, yeah.
Any more questions? Okay, thank you. Give her another round of applause for Paul Kocialkowski.